Hello everyone, welcome to Mathworld. This video is to discuss Cambridge International A-Level Mathematics Paper 3, which is the Pure Mathematics 3 for October-November 2018, and the code is 9709/31. So just for information, this paper is same as 9709/33, which is the variant 3 paper. Okay, so let's move on to question number 1. Question number 1, find the sets of values of x satisfying this inequality where a is a positive constant. So I will be using the definition of modulus x, that is same as square root of x squared. So now 2 modulus 2x minus a less than modulus of x plus 3a. So this is going to be 2 square root of 2x minus a squared less than square root of x plus 3a squared. Now to eliminate the square root from both sides, we need to square both sides. So when you square both sides, the power 2 on the left side will be moved into two terms. Okay, so move into the brackets. That means it's going to be 2 square. Then the 2 and the squared and square root will be cancelled off. I will be getting 2x minus a squared, then less than x plus 3a squared. So you will be getting 4. Then now expand the squared using quadratic expansion, that is a squared plus 2ab plus b squared. Then from here, you will be getting 4x squared minus 4xa plus a squared less than x squared plus 6ax plus 9a squared. So expand the left side, you will be getting 16x squared minus 16xa plus 4a squared, and at the same time move all the terms on the right side to the left side. So you have to change all the sign from plus to minus. Then you will be getting these 3 terms. Okay, now when you simplify all the terms on the left hand side, you will be getting 15x squared minus 22xa plus minus 5x squared less than 0. Now this quadratic can be factorized. Okay, 15x squared is basically 5x times 3x. Okay, then now here, minus times plus will be a minus. So I will have a minus and plus. 5x squared, 5a squared will be 5a times a. And then to get the negative 22xa, therefore I have to write minus 5a, so that this is minus 25ax when you multiply. Okay, then this is plus 3ax. So when you plus the middle column, it will be minus 22ax. And then for the first and third column, you multiply. That is 15x squared, then minus 5a squared. Okay, then lastly, get the factors by using cross multiplication. Therefore, you will be getting 5x minus a times 3x minus 5a, and then less than 0. So now, from the question, it's mentioned that the a is positive constant. That means now, okay, next step is sketch this graph. So when sketch this graph, since the coefficient for x squared is positive 15, therefore it has a minimum point. This will be the x-axis. Your x is positive value, therefore the first brackets, when you let it be 0, 5x minus a be 0, your x will be a over 5. And then the next one will be 5a over 3. Therefore, 5a over 3 is greater than a over 5. Oh, sorry, 1 is plus, 1 is minus. 5x plus a. Okay, this is plus. So this is negative a over 5. Because your a is given as a positive constant. So final answer, look at here, less than 0. Therefore, it will be below the x-axis. Hence, I will be getting my answer as x between minus a over 5 and 5a over 3. So that's the solution for question number 1. Question 2. Showing all necessary workings, solve this equation, giving your answer equal to 2 decimal places. So I will rewrite the question. Okay, so move the denominator to right side. 2ex plus e minus x equals to 4 times ex minus e minus x. And then for the right side, just do expansion to get these two terms. So then now, since you have 4ex on the right side and only 2ex on the left side, so I will move all the terms to the right side. So that means now 4ex minus 4e minus x minus 2ex minus e minus x equals to 0. So the first and third term, when you simplify, that is 2ex. Second and fourth term, when you simplify, is minus 5e minus x. Okay, then we have a formula. am times an, it will be a power m plus n. Okay, which means e minus x times e positive x, it will be e minus x plus x. That is going to be e0. This is 1. So this is how I eliminate the exponential minus x. So I have to times by exponential positive x, which means for the whole equation, I times by ex. So ex times 2ex, that is 2e 2x, because you plus the x together. Then minus 5 equals to 0. And now final answer, 2 decimal places. So that is the x values. Then I will get e2x equals to 2e2x equals to 5. So e2x equals to 5 over 2. Now to get the x, we need to apply this formula. Ln EA is A. Therefore, to eliminate the e, just take ln both sides. So ln e2x equals to ln 5 over 2. Left side, 2x. Okay, then x will be half ln 5 over 2. Then just press calculator. This is 0.4581. And the answer here mentioned, the question mentioned 2 decimal places. Therefore, just round up to 0.46. So that's your x value. Okay, 3, first part. By sketching a suitable pair of graphs, show this equation has exactly one real root. So since here, suitable pair graph means that you have to sketch two graphs. So the first graph is x cubed, and then the second graph will be 3 minus x. So for 3 minus x, it is a straight line because the x is with degree 1. Therefore, just need to get 2 points. So when x 0, y is 3. When y equals to 0, your x equals to 3. So now sketch two graphs. 2 graphs. Okay, so when y equals to x cubed, the basic graph, the basic shape is this. This is y equals to x cubed. So I will just sketch. Okay, this is y equals to x cubed. And now where x 0, y is 3. Let's say here is 3. And then this is 3. So here I get 2 points. Join 2 points using a straight line. It must be a straight line. So this is my y equals to 3 minus x. There's one intersection point. So you just write here, there is only one intersection point. Hence, the equation x cubed equals to 3 minus x has only has exactly one real root. Has exactly one real root. The number of roots depends on number of intersection points. So done for this part. Now part 2, given, show that if the sequence of real values given by this formula converges, then it converges to the root of the equation in part 1, which means you need to get the part 1 equation from the formula. Okay, so now, first of all, ignore or cancel off all the subscripts. Then now, just move the denominator to the right, to the other side. So x times 3x squared plus 1 equals to 2x cubed plus 3. Then do expansion for left side to get 3x cubed plus x. Right side, just rewrite. Now go back to the question here. We need to get x cubed and 3 minus x. So means that all my x cubed should be on left side. And then 3 minus x on the right side. So you move the plus x to the right side. Then left side will be x cubed. And then right side 3 minus x. So we have shown. Okay, done for the part B, part 2. Okay, part 3. Use this iteration formula to determine the root correct to 3 decimal places. Give the result of each iteration to 5 decimal places. So rewrite the formula. Now, for the initial x, you can refer to the graph. So I know that it is in between 0 and 3. So you can use 0 or 3 or the middle value. It's up to you. So I will be using 3. Okay, as the initial x. So now I let my x not be 3. Then now my x1 will be 2 of 3 cubed plus 3 over 3 times 3 squared plus 1. Now 5 decimal places for the working. So this is 2.03571. So now for the final answer, 3 decimal places. That means you should get same 3 decimal places. Then only you stop the calculation. So then here, obviously they are not the same. Then just continue. And it is same as 1.47945. Okay, then just continue to get x3. Then you will be getting 1.25244. Okay, so when you compare 3 decimal places, still different. So x4, just replace the x by the latest value. And then you will be getting 1.21440. Okay, 1.21440, still different. So continue for x5. Then this is 1.21341. Okay, so now it is different. What to do is I need to calculate x6. So then I will continue over here. My x6. And this is going to be 1.21341. So when you compare with the previous calculation, here 213, this is 213. Okay, so now we stop the iteration and refer to this calculation. Therefore, my x is approximate to 1.213. That is correct to 3 significant figures. For question number 4, given two parametric equations where theta is between 0 and pi, get the expression for dy dx. So now x equals to 2 sine theta plus sine 2 theta dx over d theta, because your x in terms of theta. Now differentiate sine theta, it will be cos. Keep the 2. Differentiate sine 2 theta. Okay, now differentiate sine mx plus b. That is cos, rewrite the mx plus b, differentiate mx plus b is m. Okay, therefore I will be getting plus cos 2 theta, differentiate 2 theta is 2. Then from here the 2 is in common, you can just factorize the 2. And now for the y, that is 2 cos theta plus cos 2 theta. Now when you differentiate cos, it will be negative sign. So I'll get negative 2 sine theta. Same goes to the cos 2 theta here. I will change to negative sign first. Cos change to negative sign. Rewrite the 2 theta. Differentiate 2 theta is 2. Then from here, the minus 2 is in common. Okay. So lastly, my dy over dx. Then it will be dy over d theta divided by dx over d theta. Then from here, I will say that is minus 2 sine theta plus sine 2 theta over 2 times cos theta plus cos 2 theta. So the 2 will be cancelled off. Okay, so when you cancel off the 2, it will be negative of sine theta plus sine 2 theta over cos theta plus cos 2 theta. So that is your dy over dx. Part 2, hence. Hence means use a previous answer. Find the exact coordinates of the point on the curve at which the tangent is parallel to the y-axis. Okay, for your information, if let's say this is a curve, tangent to the x-axis means this is the line, dy dx equals to 0. So when tangent is parallel to y-axis, right? So here is 90 degrees. We know that this gradient, since they are perpendicular to each other, means that it will be m1, m2 is minus 1. That is negative 1 over 0. So what I can say is the denominator of the gradients here will be 0. Okay, so because your dy dx is infinity. So now I will just write when the tangent, or probably I copy down the dy dx first. So dy over dx from the previous part, that was negative sine theta plus sine 2 theta over cos theta plus cos 2 theta. Okay, so now when tangent is parallel to y-axis, because when tangent is parallel to x-axis, the numerator equals to 0. Okay, then when the tangent is parallel to y-axis, that means the denominator of dy dx is 0. Cos theta plus cos 2 theta equals to 0. Then from here, I will just solve this, because now you need to find the exact coordinates of the point. Means that you need to find the x and y coordinates. So now let this be 0. And since your equation now has cos theta and cos 2 theta, cos 2 theta we have 3 expressions. So now I will just choose the expression with the cos theta. That is 2 cos squared theta minus 1. Okay, let's say this is cos 2a, that means 2 cos squared a minus 1. Okay. Then now I will be getting cos theta plus 2 cos squared theta minus 1 equals to 0. And rearrange this quadratic equation, you will get 2 cos squared theta plus cos theta minus 1 equals to 0. And now factorize this into 2 linear factors. So it will be 2 cos theta squared is 2 cos theta times cos theta. Okay, then after that, the 1 is 1 times 1. Now look at the sign here. This is plus. Plus times minus is a minus. But because we need to get a plus cos x in the middle term, therefore it should be plus, then here minus. Because plus 1 times 2 cos is plus 2 cos theta. Minus 1 times cos is minus cos theta. So that when you add up the middle term, that is positive cos theta. And then when you multiply the third column, that is minus 1. Multiply the first column, that is 2 cos squared theta. Okay, so then the factors you need to cross multiply. Therefore here I will be getting 2 cos theta minus 1 cos theta plus 1 equals to 0. So now one of the terms must be 0. That means 2 cos theta minus 1 equals to 0, or cos theta plus 1 equals to 0. Which means either cos theta is half or cos theta is minus 1. Okay, let's look at the previous question. And given that now your theta is between 0 and pi. So, when theta between 0 and pi, okay, then now when it is, that means this is in the first two quadrants. So, cos theta equals to half. Then I will be getting cos theta equals to half. Then my theta is pi over 3. Okay, inverse cos. You can say inverse cos half. Arc cos. This is what I call as arc cos half. That is pi over 3. But then when cos theta is minus 1, so I refer to the cos graph. This is my cos graph, 2 pi and pi. My theta has to be pi. Okay, but then you see the interval here. But given the theta is in between 0 and pi, does not include pi, therefore we will get no solution here. So no solution. So okay, so from here I will just say theta cannot be pi. So which means my theta is basically pi over 3. Okay, now when you are getting this, right, this is y equals to cos theta. So when you are getting this, to get the coordinates of the point, just substitute back into the x and y. Okay, 2 sine theta plus sine 2 theta for the x. So x equals to sine 2 theta plus 2 sine theta. Sorry, sine theta plus, let me check one more time. 2 sine theta plus sine 2 theta. 2 sine theta plus sine 2 theta. Then now my theta is pi over 3. That means it will be 2 sine pi over 3 plus sine 2 over 3 pi. Then you will be getting 2 times sine pi over 3, it will be root 3 over 2 plus sine 3 over 2 pi, that is also root 3 over 2. So basically this is 2 times root 3 over 2 plus 1 times root 3 over 2. Then you will get 3 times root 3 over 2. And I will say that this is actually 3 over 2 root 3. Now, my y value is 2 cos theta plus cos 2 theta. And again, replace the theta by pi over 3. So, cos pi over 3 is basically half. Cos 2 pi over 3 is negative half because that is in the second quadrant. So, it's negative for the cos. So, let's end up with 1 minus half. That is half. That means now here, I'm getting the point with coordinates. So, here, point with coordinates 3 over 2, square root 3, and half. That's the solution of this question. Question 5. Given this differential equation and the curve passes through 1, 1. Find the equation of the curve obtaining the expression for y in terms of x. This is basically solving the differential equation. Okay, probably I write here. So this can be done, this can be solved by using separable variables. Since your dy is on the denominator, is the numerator on the left side, so the y should be on the left side. Okay, and then all the x should be on the other side. And I use integrate both sides. Now for the right hand side, we can split into two integrations. 2 over x minus x squared over x is basically x. Now, when you solve integration, especially when the degree of the x of the function in the denominator is 1, then I will be using the ln. So now the numerator is f prime x. Then here is going to be ln fx plus c. So when you integrate, this is going to be ln y. Right hand side, the 2 taken out, you can factorize the 2. Then this is going to be, okay, when you factorize the 2, it will be 1 over x. So when you differentiate 1, integrate 1 over x, that is ln x. Then the next term is x squared over 2 plus c. So now, given the points 1, 1, that means x is 1, y is 1. So now replace, I'll get ln 1 equals to 2 ln 1 minus 1 squared over 2, so half plus c. So ln 1 is 0. Okay, here is 0. Left side also 0. That means the c is half. Substitute this c into the solution. Therefore, ln y is 2 ln x minus x squared over 2 plus half. Now, when you look at the question here, the question says y in terms of x. Alright, so now I need to get the y as a subject, which means I need to eliminate the ln. So, to eliminate the ln, the easiest way is just take e. Okay, then now here I will get e. I'll get e ln y equals to e 2 ln x. It's just one ln e is allowed on both sides. But then for the right hand side, I have e2 ln x. This one I can simplify, provided I split it to one term. I split the terms on the right side first, so that e2 ln x will be one term. Okay, so e ln y will be y. So when I need to split, I have to apply another formula, which is EA times EB equals to EA plus B. Okay, this is I split it. So now here I will get E 2 ln x times E negative x squared over 2 plus half. Okay, I can assume it is summation of the powers now. Then now, before I cancel the E and ln, we have another formula. Make sure the power is 1. For the ln, the coefficient for ln is 1. Therefore, this is ln b power a. So the 2 will be moved up. So I will get e ln x squared. Multiply with e. Now, the over 2 is common. So I will just combine both terms. Then e ln x squared, basically, it is x squared. Then exponential 1 minus x squared over 2. So that is your equation of the curve. Okay, part 1. Show that the equation square root 2 cosine x plus cotangent x equals to square root 3 can be expressed in r sine x minus alpha equals to square root 2, where r is greater than 0 and the alpha is between 0 and 90 degrees. So for information, if you need to get this form, r sine x minus alpha, you must get a sine x minus b cos x. Because here sine, so here must be sine and this is minus. Okay, so which means now I need to simplify the cosec and the cotangent x. So cosec is basically 1 over sine x. Cotangent x is cos x over sine x. Now since both also over sine x, I can just times the whole equation by sine x to eliminate the denominator. Therefore, you are getting square root 2 times 1 plus cos x equals to square root 3 sine x. So therefore, the cos x move to the other side and rewrite the terms. You are getting square root 2 on the right side, which is here. Okay, what I just need to do is I just need to write square root 3 sine x minus cos x equals to r sine x minus alpha. So now my r is basically square root of the coefficient of sine is square root 3. So you square the coefficient of sine plus square the coefficient of cos. That is going to be square root of 3 plus 1. That is 2. Okay, square root 4 is 2. Then now your alpha value is going to be inverse tangent 1 over square root 3. Then you will be getting 30 degrees. Therefore, my answer is going to be 2 sine x minus 30 degrees equals to square root 2. Okay. Now part 2, hence solve the equation. So exactly the same equation for x from 0 to 180 degrees. So now I will just copy the previous solution. That is 2 sine x minus 30 degrees equals to square root 2. So we are solving this. So then sine x minus 30 degrees, it will be square root 2 over 2. Okay, so when square root 2 over 2, that means you are getting, okay, now basic angle, you can just write basic angle equals to inverse sine square root 2 over 2, that is 45 degrees. So now draw the quadrant diagram. And we just consider first two quadrants because the x is given as 0 to 180 degrees. And then my angle will be 45 degrees. That will be my basic angle. Okay, now you look at here, x between 0 and 180 degrees. So now I will be solving x minus 30 degrees. So it's just minus 30 degrees. It will be from minus 30 degrees until 150 degrees. Okay, so now based on the quadrant diagram, my first angle is 45. It's acceptable because it's in the interval. My second angle is the bigger value. So therefore, I will write x minus 30 degrees. Firstly, 45. The second angle is basically 180 minus 45 degrees because it is in the second quadrant. So I will be getting 45 degrees and 135. That these two values belong to x minus 30 degrees. But now we are solving x. Therefore, you have to plus 30 degrees. Move this minus 30 to the right side. It becomes plus 30 degrees. Therefore, you will be getting x equals to 75 degrees and 165 degrees. That is your solution. Question 7. The diagram shows the curve 5 sine square x cos cube x for x between 0 and half pi and its maximum points M. The shaded region R is bounded by the curve and the x-axis. First part, find the x-coordinate of M. So now the M is maximum points. That means you need to solve dy dx equals to 0, giving your answer equal to 3 decimal places. So from here, your y is 5 sine square x cos cube x. Since this is multiplication of 2x, two functions of x, I will be using the products rule. So differentiate uv, that is uv prime plus vu prime. Okay, so now my u is going to be, my u is 5 sine square x. This is same as 5 square of sine x. Then when you differentiate this, we have another formula. Differentiate fx with degree n. That is n fx degree of n minus 1, then f prime x. Then now here, I will get, okay, the squared, I bring it down and combine with 5. That means that it's going to be 10. So u prime is 10 sine x, degree 1. So when you differentiate sine x, that is going to be cos x. So I will be getting 10 sine x cos x. Okay, then my v is cos cube x. This is same as cos x degree 3. So v prime, use the same formula, bring down the 3. Cos x degree 2, differential cos x is minus sine x. Therefore, you will be getting minus 3 cos square x sine x. Now, my dy dx, that is the products rule. So u v prime minus vu prime. Okay, so now here I will get 5 sine square x times minus 3 cos square x sine x plus cos cube x multiplied with 10 sine x cos x. Now, at m, it is a maximum point. That means the dy dx goes to 0. But before that, I need to factorize a common term. So obviously, from here, the common is the 5, because I can factorize 5 from 10. And then here is the sine, okay, followed by cos square x. So all these are the common term. That means you will be getting 5 sine x cos square x. Factorize this first. Then the first bracket, this is considered as first term. So from the first term, you will be getting minus 3 sine square x. Okay, then from the 10, you have factorized 5, therefore left 2. Then the cos degree 3 and degree 1 here, that means degree 4. So when degree 4 of the cos x, you factorize degree 2, you still have degree 2. Okay, so now you write at m, because m is a maximum point, therefore dy dx equals to 0. So when this is equal to 0, that means 5 sine x cos square x equals to 0. Or probably I just show step by step. Alright, then now product of two terms equals to 0 means one of them must be 0. So either 5 sine x cos square x equals to 0, or minus 3 sine square x plus 2 cos square x equals to 0. So again, when sine x times cos square x equals to 0, one of them will be 0. That means either sine x equals to 0, or cos square x equals to 0, or minus 3 sine square x plus 2 cos square x equals to 0. Okay, so now look at the x values. The x is from 0 to half pi. Okay, and then the m is in between 0 and half pi. So now, when x in between 0 and half pi, sine x equals to 0. So now I refer to the sine graph. Sketch your sine graph. This is 2 pi. Here is pi and 0. Maximum 1, minimum minus 1. So this is y equals to sine x. That means that x equals to 0. Okay, when cos square x equals to 0 means that, okay, so right, given so when cos square x equals to 0 means that cos x equals to 0. So when cos x equals to 0, the cos graph. Alright, this is cos x. So then, When 0 means that pi over 2. Okay, x goes to pi over 2 when we consider this interval. Now, from here, because we know that at m, look at the graph, your m will not be 0 and half pi because it's in between. So it means that here, x cannot be 0 and x cannot be half pi. Means that we do not get any solution from these two graphs. Okay, from the sine and cos. Now what we can do now here is we just solve the last equation. That means now minus 3 sine square x plus 2 cos square x equals to 0. That means 2 cos square x equals to 3 sine square x. So now I divide the whole equation by cos squared. So you will get 2 equals to 3 tangent square x. Because sine square x over cos square x is tangent square x. Then now here, tangent square x will be 2 over 3. And because of x between 0 and half pi, okay, so your tangent x will be square root of 2 over 3. Just positive because of the first quadrant. Otherwise, you get plus minus square root. Okay, so now here, I will say my x will be inverse tangent of square root 2 over 3. Okay, because the question asks for x coordinate of m correct to 3 decimal places. So now, and by looking at the interval here, it must be in radians. So change the mode of the calculator to radians. This is 0.6847. So you round up to 0.685. So that means here you can just write at m. No, you can just write the x coordinate of the point m equals to 0.685. So that's the solution of this question. Okay, now next part, using the substitution u equals to sine x and show all necessary working the exact area of R. So area, go back to the graph. Okay, area, because the region is towards the x-axis, therefore area is basically integrate y dx. And then from 0 until half pi. Okay, so now copy this as the y. So then I will be getting area equals to integrate from 0 to half pi 5 sine square x cos cube x dx. And now given u is sine x. So when u is sine x, now here, u equals to sine x, I need to get du dx, right? So du over dx will be cos x. Then now here, I can combine my cos x with the dx, because here I can factorize the cos x. So therefore, du equals to cos x dx. Now, when my x equals to 0, which is a lower limit, my u equals to sine 0, which is 0. When my x equals to half pi, my u is sine half pi, that is 1. That means now here, before I change to u, I have to change first. Now, I have the sine square x here. Now, refer to the formula, the identity, cos square x plus sine square x equals to 1. Because now you need to change it to u. So make sure there's no sine squared. You might have to change to cos. Okay, sorry. You have to change to cos. So it means that I have to keep the sine. So this sine I will not change. But then later on, I will change the cos. Okay, so it will be 5 sine square x. Because you are given the u as sine x. Then the cos cube, I will change to cos square x. And then cos x dx. Because the cos x dx will be combined together to get the du. Okay, I will change this to du. So now left the cos square x. That's why here I need to get the cos square x as 1 minus sine square x. Therefore, you will be getting equals to integrate from 0 to half pi 5 sine square x. Then the cos square x I will change to 1 minus sine square x. Then cos x dx. Then now here, change the limits from 0 to half pi into 0 to 1. Okay, when you replace, you change everything to u. So this will be your new limits. So the first term will be 5u squared. Then 1 minus u squared. Cos x dx is du. The 5 can be taken out. Then I will just need to integrate 0 to 1. U squared bring into the bracket. That means you will be getting u squared minus u degree 4 du. And when you integrate, you are adding 1 degree. So u cubed over 3 over the new degree, u degree 5 over 5. Limits will be from 0 to 1. And now replace the u by 1 first, the upper limit. Therefore, you will be getting 1 over 3 minus 1 over 5 minus when the u is replaced by 0. So at last, you will be getting 5 times 2 over 15. That is going to be 2 over 3. So this is your exact area of the graph, of the shaded region. So 8a, showing all necessary working express the complex number in REI data. This is a Euler form, where the data is between minus pi and pi. Give the values of R and theta correct to 3 significant figures. So now, 2 plus 3i, firstly, I will simplify this complex number. So this complex number can be simplified by multiplying the conjugate of the denominator, which is 1 plus 2i. So for the numerator, just do expansion. 2 times 1 plus 2i, you will get 2 plus 4i. Then 3i times 1 plus 2i, it will be 3i plus 6i squared. For the denominator, we have another formula. A minus bi times a plus bi times the conjugate, it will be real squared plus imaginary squared. Therefore, I will be getting 1 squared plus 2 squared. Okay, then from here, now remember, I squared is minus 1. That means this is minus 6. Because I squared is minus 1. So 2 minus 6, that is minus 4. Okay, then 4i plus 3i, 7i. Now denominator, it will be 5. So then from here, I will split it into real and imaginary parts. Minus 4 over 5 plus 7 over 5i. Now, I will get my r and theta from this expression. So now from here, my r equals to, that is the modulus, which is square root of minus 4 over 5 squared plus 7 over 5 squared. Then, now, r and theta correct to 3 significant figures. So then from here, you can just calculate directly what is the value correct to 3 significant figures. That is going to be 1.61. Okay, and then for the theta value, which is a principal argument, you need to draw the Argand diagram. So the real part is negative 4 over 5, and then the imaginary part is 7 over 5. This is your 7 over 5. This is real axis and imaginary axis. So my point is over here. Now just join to the O. This is your theta. Okay, so now theta equals to, your inverse tangent is basically this part. Okay, this part. Therefore, theta is pi minus inverse tangent of, because we know that here is 7 over 5, and then this is 4 over 5. That it will be the opposite side, 7 over 5, and the adjacent side is 4 over 5. So it will be 7 over 5 divided by 4 over 5. Okay, then you will be getting pi minus inverse tangent of 7 over 4. And now remember, the answer requested 3 significant figures. So now just use your calculator and change it to radians mode. Then you will be getting 2.0 9. Okay, therefore it will be 1.06, it will be 1.61 E 2.09 I. So that's the answer of this question. Now B, on an Argand diagram, sketch the locus of the points representing the complex numbers z satisfying this equation. Find the least value of modulus z for points on this locus, giving your answer in exact form. So now, modulus z minus 3 plus 2i equals to 1. This is basically the equation of a circle. But then the original form is z minus 3 minus 2i. You must factorize a minus from the real and imaginary part because that is the center. So this is basically a circle with center 3, negative 2 because of 3 minus 2i. Then now the radius is 1. Okay, so now we sketch a graph, or we sketch the locus. Okay, we draw the locus. So our center is at 3 minus 2. So this is the real part, real axis. So 1, 2, 3. Minus 2 means 1, 2, 3. Minus 1, minus 2, minus 3. Okay, so the center is at 3 minus 2. Now the point, because of radius is 1, so it will be touching at all these points. So always 1 unit left, right, up and down. Then your circle will be touches all these points. So draw a circle. Right? So therefore from here I will label this as modulus z minus 3 plus 2i equals to 1. Remember, this is a circle. This is a center. So probably I draw again this part. Okay, now the question says find the least value of modulus z. So the z is the points on the orange color. Okay, that means the circumference of the circle. So the modulus is counted from the origin. So obviously, right, this will be the smallest. That means up to here. This is the smallest. I need to find out this. And I know that here is 3, 4. The center is 3, 4. Okay, and then the radius is 1. So because the radius is 1, here is 1 unit. Right, the blue line is 1 unit. And now you need to find out what is a green line. So then I will just use 2 points, 0, 0 and 3, 4. Then I can find what is the green line plus the blue line. So now 0, 0, 3, 4. So the distance is basically, you refer to the distance of 2 points. Let's say A is x1, y1. B is x2, y2 coordinates. So the distance AB equals to square root of x1 minus x2 squared plus y1 minus y2 squared. Okay, so I'm going to use this formula. That means here is going to be square root of 3 minus 0 squared plus 4 minus 0 squared. Therefore, sorry, it's not 3, 4. It is 3 minus 2. Okay, mistake. The distance, the center is at 3 minus 2. So here is supposed to be 3 minus 2. Then you will be getting square root of 3 square plus, I calculate directly. 3 square is 9. So minus 2 square is 4. Therefore, square root 13. So I know that the total length here is square root 13. But then our least modulus is the green color. So this is the least modulus z. Okay, so because the radius is 1, here is 1, so the green color is basically square root 13 minus 1. So the least modulus z is basically square root 13 minus 1. Okay, so that is the solution of this question. Okay, now next question, number 9. Express fx in partial fractions. So first of all, check this is x squared, but here we expand, it will be x degree 3. So this is proper rational function. Therefore, we can find the partial fractions directly. So 6x squared plus 8x plus 9 over 2 minus x times 3 plus 2x squared. This is going to be a over 2 minus x plus, you are given a repeated linear factor, so b over 3 plus 2x plus c over square of 3 plus 2x. And now here we need to get the same denominator as on the left hand side. Therefore, I need to multiply with the repeated factor. Then for the b, the second term, b over 3 plus 2x, because now you are given 3 plus 2x degree 1. So it means that now I need to multiply with 2 minus x and then 3 plus 2x. Same goes to the c. So plus c over 3 plus 2x squared. I need to multiply with 2 minus x over 2 minus x. Okay, so now once you get the same denominators, then you can just ignore all the denominators. So just consider all the numerators. Then now 6x squared plus 8x plus 9 equals to a times 3 plus 2x squared plus b times 2 minus x, then 3 plus 2x together with the c, then 2 minus x. Then from here, to get the unknowns, let the factors be 0. So I will let 3 plus 2x be 0. That means now your x is going to be negative 3 over 2. So just replace the x in this equation. So but then whenever you see 3 plus 2x, right, that will be 0. So no need to calculate. That means you are counting c now. So equals to c, 2 minus negative 3 over 2. So the left hand side is going to be 21 over 2. Then right hand side is c times 7 over 2, which means now your c is 3. So next is let the second factor be 0. So let 2 minus x be 0. That means your x is 2. So now replace the x by 2. 6 times 2 squared plus 8 times 2 plus 9. Then the first term, a bracket 3 plus 2, 2 squared. Okay, the b and c you can't find because of the 2 minus x, the factor. So what to do now here is, left hand side it will be 49. Right hand side, 4 plus 3 is 7. 7 squared is 49. So you are getting 49 is 49a. Therefore your a is 1. Now we have used up all the linear factors on the right side. So to find another unknown, just let x be any numbers. Let's say x be 0. So left hand side is 9. Right hand side I will get a times, okay, the a is replaced by 1. Then 3 squared. The b remains 2 minus x, 2 minus 0. Then times 3. C is replaced by 3. 2 minus 0 is 2. So here 9 equals to 9 plus 6b plus 6. So the 9 will be cancelled off from both sides. Therefore 6b equals to minus 6. At last, your b is minus 1. So with this, we have found all the unknowns ABC. Just replace back into this these partial fractions. So then I will get fx equals to a over 2 minus x. So my a is 1 now. So 1 over 2 minus x. The b is minus 1, so minus, because initially it was plus b. So plus times minus 1 is minus 1 over 3 over 3 plus 2x. And then the c is plus 3. So here plus 3 over square of the linear factor. This will be the partial fractions. Okay, next, hence. Hence means use the previous answer, showing all necessary working, or showing all necessary working, show that the integration equals to these two terms. So now, integrate from minus 1 to 0, fx dx. This is same as minus 1 to 0. So copy down all the fx that we have found just now. So copy down all this. 1 over 2 minus x minus 1 over 3 plus 2x. Then plus 3 over 3 plus 2x squared. Okay, so for this integration, I will split it into 3 integrations, because whenever the degree of the denominator is 1, the whole function is degree 1, then I will be using the ln formula. This is the ln formula. Okay, but for the last term, it is degree 2. So when degree 2, you have to move up and use this formula. This is going to be ax plus b degree n plus 1. Then over n plus 1, and differentiate ax plus b, that is a, then plus c. This formula is valid when n is not minus 1. So that means now here, you will be getting equals to integrate from minus 1 to 0, 1 over, or I will write over 2 minus x first. So when differentiate 2 minus x, that is minus 1. Write a minus outside to get positive 1. And then minus integrate 3 plus 2x dx with limits. Then when differentiate 3 plus 2x, that is 2. So to get back this 1, I will have to times half outside. Lastly, move up the square. So take out the 3, minus 1 to 0. 3 plus 2x degree negative 2. So now for the first one, that is negative ln of 2 minus x. Second one is negative half ln 3 plus 2x. And then the last one, it will be using this formula. Rewrite the 3 plus 2x degree. Now minus 2 plus 1 is minus 1. Then over minus 1, and differentiate 3 plus 2x, that is 2. Now with limits minus 1 to 0. Okay, so here is going to be negative ln. I rewrite first because I want to simplify the last term. So 3 divided by negative 2, that is negative 3 over 2. And then the numerator is with degree negative 1. Look at here. Therefore, I will move it down. So hence you are getting negative 3 over 2 bracket 3 plus 2x. And then with limits minus 1 to 0. So now replace the x by 0. So it will be negative ln 2 minus half ln 3. Then minus 3 over 2. 3 plus 2 times 0 is 3. Then minus everything is minus 1. So I get negative ln 2 minus minus 1 is 3. Then minus half ln 3 minus 2 is 1. Then minus 3 over 2 times 1. Okay, now when you open the brackets, so it will be negative ln 2 minus half ln 3 minus, okay, now the 3 can be cancelled off. That is half. Then this minus, bring it in. It will be plus ln 3. Now, ln 1 is 0. So this is 0. Can be ignored. Then the minus and minus is a plus. So next term, plus 3 over 2. Now look at the question here. you need to prove 1 plus half ln 3 over 4. So now for the numbers negative half plus 3 over 2, that is already 1. So I will rewrite 1, and then look at the question here. Given plus half, you need to show it's plus half. So which means now, even though the first term is negative ln 2, I will change to half, right? So it means I factorize half from there. Then I rearrange. I let the plus ln 3 be first term, then minus half ln 3 minus ln 2. And now here, for the last 3 terms, I factorize half. So when you factorize half from ln 3, that is 2 ln 3. Factorize half from minus half ln 3, that is minus ln 3. Then lastly, it will be minus 2 ln 2. And now when you look at the question here, it is half. We already found the half. I need to get ln 3 over 4. That means now here, right, before I combine the 3 ln, make sure you change to this form. A ln b is ln b power a first before we combine. Therefore, this is going to be ln 3 squared minus ln 3. Okay, then minus ln 2 squared. So the last 2 terms can be combined, can be factorized the minus. So ln 3 squared is basically ln 9. Then minus ln 3 plus ln 2 squared is 4. That means now I will combine the ln. So ln a minus ln b, that is ln a over b. At the same time, ln a plus ln b, you will be getting ln a times b. So it means that now I will write half ln. You see here 9 minus means divide. Then there is a bracket ln 3 plus ln 4. That is ln plus together, so you will get 1 ln, right? Probably I will just do like this. It will be ln 9 minus ln 12, because 3 times 4 is 12. Then it will be 1 plus half ln 9 over 12. So 9 over 12, you can divide by 3. Both are the factors of 3. So it will be 3 over 4. Therefore, I have found the answer. Okay, half ln 3 over 4. Question number 10. The planes M and N have equations, respectively. The line L has another equation. Show that L is parallel to M. Okay, now firstly, M, it is 3x plus y minus 2z equals to 10. Now I will change to the vector form, which is r dot 3, 1 minus 2, because 3x, 1y minus 2 equals to 10. So which means my NM, okay, vector, the normal vector for the plane M is 3, 1, negative 2. Now for the line L, R is equal to 4i 2 plus 2j plus k. So I can express in this form, 4, 2, 1 plus lambda 1i 1j 2k. Therefore, from here I will get the direction vector B, because the vector equation of the line is basically r equals to a plus lambda b, or a plus tb. So the b is 1, 1, 2. And now you need to prove L is parallel to M. Let's say this is L. This is M. So for the L, we have B, direction vector. For the M, which is a plane, we have normal vector. So if they are perpendicular, if they are parallel to each other, the line and plane, the B is perpendicular to the N, right? And M. So that means now to show perpendicular, I have to show the dots product. So B dots and M, that will be 1, 1, 2 dot 3, 1, negative 2. So the dots product is basically multiply the corresponding components. Then you will get 3 plus 1 minus 4. So I'm getting 0. So since the B is perpendicular to NM, hence L is parallel to the plane M. Okay, so done for the first part. Now part 2, calculate the acute angle between the planes M and N. Now, for the M, I have found the normal vector just now. That is 3, 1, minus 2. So now for the plane N, okay, the vector, the Cartesian equation, this is called Cartesian equation, x minus 2y plus 2z is 5. So x minus 2y plus 2z is 5. I can change to the vector form, that is r dot 1x negative 2y 2z equals to 5. That means the normal vector of plane N is 1, negative 2, 2. So now the acute angle between the planes will be same as the acute angle between these two normal vectors. So I let the theta be the angle between M and N. Okay, between two planes. That means here it will be N M dot N N. That is the scalar product formula. Modulus N M modulus M N cos theta. Okay, so now when you get the dots product of these two terms, you just multiply the corresponding components like what we have done in the previous part. That means you will get 3 times 1 plus 1 times minus 2 plus minus 2 times 2 equals to square root of the modulus is basically square of each component. Square of sum of the components. Square of the components. Sum of the squares of the components, right? Then here cos theta. Then for the left hand side, you will get minus 3. Then the first square root is square root 14. The second square root is square root 9. After that, cos theta. So the cos theta is minus 3 over square root 14 square root 9. That means now your theta will be inverse cos of the right side. Therefore, I will get theta is inverse cos negative 3 over what we call this as at cos. Okay, at cos. Then you will be getting 105.5 degrees. But then when you look at the question here, you need to calculate acute angle. So acute angle is basically just use 180 minus that value. Then you will be getting 74.5 degrees. So that's the solution of this question. Part 3, a point P lies on the line L. The perpendicular distance of P from the plane N is equal to 2. Find the position vectors of the two possible positions of P. Okay, let's say this is a plane N. Okay, this is the L. Here is the P. The perpendicular distance here is 2. So now you need to find 2P. Okay, two position vectors of the P. So that means now here, since P lies on L, P lies on L. Okay, therefore OP same as RL, which is the line equation. So just consider this whole equation. Right? So I combine the two column vectors. That will be 4 plus lambda, 2 plus 1 lambda here, and then 1 plus 2 lambda. That will be your OP. So I will get 4 plus lambda, 2 plus lambda, 1 plus 2 lambda. That's your OP. Okay, now the distance formula, the shortest distance from a point P to the plane N. Okay, the formula is r dot n hat. This n hat is actually the n from the normal vector from the plane N minus p dot n hat. It's also from the plane N. So now, for your information, the plane equation is actually r dot n equals to a dot n. So if you need to get r dot n hat, so if I need to get hats here, I just get hats here. So how to get hats from the n? Therefore, the hat is basically the units vector. So that means you divide, okay? Divide by the magnitude. So divide by magnitude. That means now here, you will be getting r dot n hat equals to a dot n hat. Right? So initially it was r dot n equals to a dot n. This is the vector equation of the plane. Therefore now, when you refer back to the plane N, okay, plane N is here. This is a dot n. Alright, so I will just take this over the magnitude of the 1 minus 2, 2. That will be the a dot n hat. So I will write 5 over, and in the question is mentioned that the distance is 2. So 2 equals to modulus of 5 over square root of 1 square plus negative 2 square plus 2 squared minus the p is here. So 4 plus lambda, 2 plus lambda, 1 plus 2 lambda dots with the n hat. So it means that it will be 1 minus 2, 2 over square root 1 square plus minus 2 square plus 2 squared. Okay, so now from here I will say that 2 equals to modulus 5 over this is basically 3, then minus just do expansion, sorry. Okay, now the dot product of two vectors just multiply. So it will be 4 plus lambda times 1 plus 2 plus lambda times minus 2 plus 1 plus 2 lambda times 2, then over 3. Okay, then now here the 3 can be taken out, and the modulus I can change to plus minus, because after modulus it will be always plus. So it will be plus minus 6. Right, this 3 taken out. Then now I will get 5 minus, so all this just do multiplication. I will be getting 4 plus lambda minus 4 minus 2 lambda plus 2 plus 4 lambda. Then now here I will get 5 minus, okay, look at here. The 4 and minus 4 cancel off. So here will be 5 minus 2, that is 3. So for the lambda, 4 lambda plus 1 lambda, 5 lambda, minus 2 lambda is 3 lambda. So there is a negative outside. Therefore, I get minus 3 lambda equals to plus minus 6. Now, I have to solve the lambda value because we need to calculate the OP. Okay, OP depends on the lambda value. So, I will split it into 2. 6 equals to 3 minus 3 lambda, or minus 6 equals to 3 minus 3 lambda. Therefore, this minus 3 lambda move to the other side. Just rearrange it. So 3 lambda is 3 minus 6, that is minus 3. Lambda is minus 1. Therefore, the other one, your 3 lambda equals to 3 plus 6, which is 9. Lambda is 3. So with 2 different lambda, you will be getting 2 OP. So your OP will be, just replace your lambda here, right? Just substitute the lambda. So you will get 4 plus lambda. That means it is 4 plus minus 1. Then 2 plus lambda. 1 plus 2 lambda. Okay. So now here will be 3. 2 minus 1 is 1. 1 minus 2 is minus 1. And same goes to the next lambda value, which is 3. So your OP will be 4 plus 3, 2 plus 3, and then 1 plus 2 times 3. Then you will be getting 7, 5, and 7. Okay, so done for the 2 position vectors of P. Okay, so I have completed the whole paper and also comes to the end of the video. Thanks for watching. Please subscribe to the channel if you enjoy watching my video, and also like the video. Okay, so then don't forget to share this channel with your friends as well. And also stay tuned for more upcoming videos. Thank you everyone. Bye.